Yo, what's good, y'all? This time with a conceptual studying video. Funny enough, I've never studied ternary search, even though it's a very common concept. In fact, if you go to code forces, and then you go to wait, hold on. Was it top? Oh no, it was catalog, right? If you go to catalog, there's gonna be a list of pages that you should go through. And the first topic you get into is binary search, obviously. And then there's ternary search, multidimensional ternary search right here. Now, obviously, this isn't in order. You won't be learning about parallel binary search in your first lesson of competitive programming, or just programming in general. But it's a pretty wide concept that I should have learned by now, I think. And well, so I'll be learning it right now, because why not? Alright. I read through a little bit before everything, before recording this video. Okay, so we have a unit model function. I think that's how you read it. So basically, it's just those functions that have a clear minimum or a maximum. It can either be this way or this way. Yeah, that's how it's gonna go, and our goal is to find this point. And I assume that it should be better than linear time, because we can obviously find the minimum in linear time, so it has to be further optimized than that, and I'll be going over that. That just defines unit model. Okay, so we assume the first, it doesn't matter which one we take, and we want to find the maximum. So we're assuming this one, the second one here. Doesn't really matter though. Okay, so I'm pretty sure it's somewhat similar to binary search in a sense. So in binary search we would consider one midpoint, but here we have two inside the open interval L and R, and then we evaluate the functions. Okay, so we evaluate the function values when given the m's. Yeah, if m1 is smaller than m2, then we know that the maximum cannot be located on the left side of m1. Yeah, because obviously there's a bigger value, clearly. The same goes vice versa. That's pretty obvious. When they're the same, we know that the maximum has to be in between, because they can't both be the maximum, I'm guessing. Or even if they are both the maximum, I mean, then we've found the maximum. If there's two values of the same, and if they're somehow the maximum, then we can just refer to those values. They might discuss some more about that, but I'm not sure. Yeah, we're continually decreasing the range, and then we get an arbitrarily short interval. Okay, less than a certain predefined constant, and yeah, once we get to a certain accuracy, then we can be okay. That makes sense. Wait, maybe this isn't specifically about like an array of values where f is like a given like list. Maybe it's actually mathematical entirely. Give me a moment. Alright, I'm back, yo. Anyways. We'll log, we can take FL as the result, and that's the return value. So we stop when like R minus L is probably lower than our accuracy, and I think that was epsilon here. Would usually be epsilon. Yeah, because for an actual function there are infinitely many points, so we can't we can't just find the points. We can't iterate through. I don't really get what it's doing though. Like f, what is this? What is f? That's my question. Okay. Yeah, that makes sense. That's easy. We can also define this as L plus 2 times that, probably, but okay. I guess this is way cleaner. So yeah, I knew it was gonna be in a Wikipedia page. What's that like? What's that notation? T. Oh, so Tn equals T 2n divided by 3 plus O of 1 is the recurrence relation, I'm guessing. And that the final runtime is Whoa, what is going on here, bro? Wanna copy and paste the... What is that symbol? What's that weird O with the I in between it horizontally? Is it the same as big O? And by the way, guys, I'm studying this topic right now because I'm trying to use it for my calculus assignment that I have. I'm trying to explain like how it can be used in it and why it's intuitive, I guess. Oh, it's Knuth's notation, like Don Knuth. Not even sure if that's how you pronounce the name, but big theta, okay. Bro, I'll be back. Alright guys, I'm back. I had to log in, fix the Wi-Fi a bit. Okay, what were we doing? Okay. Explain Knuth notation of big O as big theta. What's the difference? Yeah. Oh, okay. I barely knew much about these two. I mean, I've seen this, but I just assumed it was the same as O, and like it was like just a different way of writing it. But every day we learn something new. Okay, so big theta is a tight bound, but Knuth used big O like big theta. Okay. So it's approximately log n, and here log is just with any base. I don't think it's immediately base 2 because Why would it be base 2? It would rather be base 3. Because we're making the range we go through a third of the original size. So it's gonna be times a third, times a third, times a third every time until that get times a third gets multiplied and gets exponentially smaller. So it'll probably be base 3. Yeah, this makes sense. So this would improve time complexity to log. Yeah, n to log base 3n. While as for this though, that's more like an actual f being an actual function. Yeah. Okay, I get it. It's actually pretty simple. Yeah, we should. I don't. When would you need to use ternary search though? There's a lot of problems here. These logins. I'll be back. All right, I'm back. So it can be used in problems like this. It's a div1c. Ooh, an old one though. You're given a sequence of n integers to determine a real number x such that the weakness sequence is min as well as possible. The weakness is defined as the maximum value of the cornerstone. Okay, all right. And there's probably some weird time complexity reason that we can't use normal iteration. Okay, I get how it's used. We should add this to our code typer. Why not? Yeah, why not? I'll switch up the indentation and other stuff to in a way that I like it, but the music's so nice every time I hear it. Hold on. Delete this, man. I don't want to see this in my face anymore. This crazy ass problem. Yeah. I'll just exit out. I just needed the done directory. Cool. Should I practice writing in this notation-ish thing? Let's ask ChatGPT ways to notate numbers in C++. For example, I know, or there must be more. Explain how each works. Well, that boots up. I'll just write the lines in a way that I feel comfortable writing. I'll define a step. like that. I'll notate that it's per maximum. Let me check correctness in my mind for a moment. So we know that it's not behind M1, so we take and reduce the range if it's not. Okay, that's really clean. There's no way we can't write this on the spot. This one's okay. That might be foreshadowing. I don't know, but yeah. New Ternary Search. Ooh. Yeah, that's nice. Alright. Oh! This was not that. Of course, epsilon's probably gonna be a tiny ass number. Oh! Oh! Alright, okay, that was. Oh! That would have been crazy. Okay. Use hexadecimals. Okay. Yeah, I know those. Can I write something like 29 plus 1? And that would be. Oh! Huh? Huh? What? Why can't I convert that into an int? Okay, we're just gonna stick to our way of notating it. When we ever need like small numbers, sure, we'll go for 1e minus 9, but other than that, I think I'll stick to my original notation. It's nice to know that this exists, but it's mainly for doubles, which is nice to know. Yeah, that wraps up our really short episode for today. I'll be doing my calculus assignment based on this. Just for the sake of it, how about we do a quick round of Ternary Search, and we'll call it a day. You guys can just leave, because this is gonna be boring as hell for you. Ternary Search. Wait, it's too tiny. Hold on. Okay, I'm definitely gonna add a feature so that I can like actually like bring my cursor out to scale the menu, the UI, the window. We take our. Oh! I am not a fan of that. No, why you do this to me? Why you make me gotta change it and everything? Oh. God. Ternary Search. Yeah, I should have written that line as well. Yeah, that makes sense. Huh? We gotta refresh first of all. What do y'all think about the UI? Because I personally love it. Okay, we take our range, obviously, and then we'll define epsilon. We can define this out of the function as well as like a constant. While r minus l is bigger than epsilon, just like how we do r minus l is bigger than 1 for binary search. We define our step. I mean, you don't have to do it like this, but I like doing it like this, so. And then we define m1. And then we check if the value is... Okay. Here we know that because we're searching for the maximum, we can cut off that range, everything from L to M1. And same goes for vice versa. Really simple stuff. We can probably just do FR as well there, because the difference is epsilon, so. GG's. I'll see y'all in the next problem.